Hi there, welcome to your lesson on the midpoint and distance formulas. Something you might be familiar with, but we're going to take these to the next level today. Alright, let's begin with this. The question is, how do you find the midpoint between 2 points? So let's say we know these two coordinates, 2, 3 and 7, 9, and we want to find the midpoint right here, which is right in the middle of that segment. Well, if you have it on a coordinate plane like we have here, it's pretty easy to find. You can kind of just count squares and check what the location is. But imagine you didn't have the coordinate plane. What would be the process here? So let me walk you through it to remind you where the midpoint formula comes from. So here's how we begin. If we want the middle of this segment, we can think of this as the middle of the horizontal movement that we've done and also the middle of the vertical movement. So I'm going to begin by kind of drawing these two segments in to make this a right triangle. So again, this midpoint on this segment is like the halfway point along the horizontal movement and also the halfway point on this one. So looking horizontally, we've gone from an x value of 2 to an x value of 7, which I see here. So we've gone a total distance of 5 units. Now, if we're going to arrive at the midpoint here, we're going to have to go to the midpoint of this segment. And if this whole distance is 5, then the midpoint must be 2.5 units from each end, right? And 2.5 units from 2 brings us to 4.5. Or 2.5 units back from 7 brings us to 4.5 as well. So that means this value here must be 4.5. That is the middle of that segment. Let's do the same thing along the vertical movement here, the y-axis. All right, that entire movement goes from 3 to 9. We can see 3 to 9 here. So that means there's a distance of 6 between there. And the middle of that 6-unit move there would be 3 units in each direction, right? And if you go 3 units up from 3, you arrive at 6. If you go 3 units down from 9, you arrive at 6 as well. So the midpoint y coordinate must be 6. So that's kind of the background of where midpoint comes from. One other thing I should note here, we're not always going to be figuring out the distance and then counting backwards from each end and so on. The way to look at this is, if we want to find the middle of a segment, we just have to find the average of the two numbers. So here's the midpoint. And I want to just point out, and this is really important, that these two numbers that we got are just averages. This is the average along the x-axis, and this one is the average along this, because average is a middle, right? So the average along the x-axis, well, this x-coordinate is 2, and this one is 7. So we do 2 plus 7 divided by 2. That's how we find an average. So 2 plus 7 divided by 2, and guess what? It gives us 4.5. That tells us what is exactly in the middle here, which is this x-coordinate. Same thing on the y-axis. The two y-coordinates were 3 and 9, so we add those and divide by 2. We're finding the average between 3 and 9, and it is 6. And notice that that gives us the same value we had here, that middle value of this part here. So averages, remember that. Now let's switch to talk about the distance. We want to know now the distance between these 2 points. These are 2 different points than we just saw. But anyway, let's say we have 2 points in space and we want the distance between them. Well, the way to approach this is just treat this again as a right triangle and use the Pythagorean Theorem. We know the Pythagorean Theorem can give us the length of a hypotenuse, so why don't we create a right triangle like this and then find the length of the hypotenuse, because that will be the distance between these 2 points. We can always make a right triangle like this. All right, so now, what is this distance or this length in this right triangle? Well, we know that this goes from x value of 2 to x value of 9. So what I did is 9 minus 2, and I know this has a length of 7. How about this one? How long is this one? Well, that one goes from a y value of 3 up to 8. So 8 minus 3, that must have a length of 5. So now let's do Pythagorean Theorem. 7 squared plus 5 squared equals d squared, that distance, the hypotenuse. Okay, take the square root of both sides. Oh, sorry, I did those squares first. Take the square root after that, and we have 8.6. That is our distance here. So now you've had a little recap of midpoint and distance formulas. Both of them come from the idea of looking at a right triangle rather than just that segment, and using the right triangle to help us find things. Okay, so now let's recap in a more abstract way with no numbers. Let's say we have a segment with 2 endpoints. This one is 0.1 and this one's 0.2. So we're going to call these coordinates x sub 1, y sub 1 to represent point number 1. And here, x sub 2, y sub 2 to represent point number 2. Now the midpoint formula, we said again, was just the average of the x values, which will bring us to the middle here in terms of x, and the average of the y values, which will bring us to the middle for the y, and that will be the midpoint. So the average, then the midpoint, again, the average is you add the two x values, divide by 2. That gives you your average x value. And then divide the y values, add the y values, divide by 2. That gives you the average y value. Great. So that is the midpoint formula. And now you know where it comes from as well. Now let's look at distance. Distance, we said, was like making a right triangle and running Pythagorean theorem. We need this length. This length is found by doing this value minus this value, and that gives us that length. And over here we do this y value minus this y value. We get that length. So these represent the lengths, and then we run the the Pythagorean theorem on those two lengths in this right triangle. So this distance squared equals this value squared plus this value squared. We see that here. And then take the square root on both sides to get just d, and there's our distance formula. So I think you probably recognize these two, but I really want to run you through the process, where they come from. It's important to know where formulas come from rather than just use them without understanding where they come from. All right, so to summarize, our midpoint formula in a two-dimensional space, the midpoint of the line segment joining points A and B is this. There's our midpoint formula. And the distance formula into the space, the distance between 2 points is this. All right, so if you haven't yet, please note down those two formulas, and now we're going to use them. First problem, the points A and B are the endpoints of the diameter of a circle. Find the length of the diameter, find the center of the circle. Okay, so these are kind of problems you're often going to see. Here's a circle, and it says that A and B are the endpoints of the diameter. So here I've drawn the diameter. A diagram always helps us understand a problem. So here's a diameter. We want to find the length of this diameter, and we want to find out the coordinates of the center. And we know point A and B, they are given to us here. Okay, so length, well, the length is the distance, right? The distance from A to B. So how about using the distance formula for part A? All right, check your work now. There's a distance formula. One common mistake students make is with all these negative signs here, for example. So I did x2, 0, minus the first x value. So I have minus and then minus 3. Make sure you have two negatives there. Anyway, if you proceed with that using correct cancellation of those two negatives and so on, we end up with 9 plus 4 here. This is 9, this is 4, and the distance is the root of 13. Of course, you can give that as a decimal value, but we can leave it as a root. Now, question B, find the center of the circle. Well, the center is here. We need to know where it is. And luckily, we know when we look at the diameter of a circle, the center is exactly halfway along that diameter. So it is the midpoint of this diameter. So how about finding the center by treating it as a midpoint of this segment? We're using the midpoint formula. All right, putting the numbers in, we're taking the average of the x values, average of the y values, and we should get this midpoint here. I hope you were successful. Okay, that's a basic application of both rules. Let's keep going. How about this one here? You are given the midpoint this time, and it says that these are the two endpoints, this one and this one. So notice you have the midpoint, you have one of the endpoints completely, but you're missing one of the values in this endpoint. So, why don't we try the midpoint formula? And I'll give you a hint on how to start this one. We are given the midpoint, so I write it here. And then putting everything else I know into the midpoint formula gives me this. And our goal is to find x. What is this unknown value? So, you know that this negative 3 comes from this calculation here. So how about ignore everything else and just focus on this negative 3 and setting it equal to this, because that's where it comes from. And we know that this 7.5 comes from here. You can actually check. 5 plus 10 is 15 divided by 2 is 7.5. So this produces 7.5. It matches. But this one, try it. Negative 3 must produce, or this calculation must produce negative 3, because that's the one coordinate of the midpoint. So solve for x here. Okay, following through, multiply by 2 on both sides, and then move the 1 over. I got x equals negative 5. So now we know that that coordinate is negative 5. of this point A. So part 2 of this problem is find the length of AB. Well, now that you know the two endpoints fully, because we just found this x value, we can use the two endpoints to find the length of that segment. That's just distance formula. Try it out. Okay, let's check how you did. So here are the numbers substituted into a distance formula, and I got a distance of the root of 41. I hope you're also successful, or check your work carefully. All right, try this one out here. Okay, I kind of left you on that one there, but again, it's similar to the last one. We know the midpoint, the center, 8, 3. And then we know the midpoint comes from this midpoint formula. In the midpoint formula, however, we don't have point A at all. So I have an unknown x value, the x value of that coordinate, and an unknown y value. So I left both of those empty. But just like the last problem, we can say now this 8 comes from this, and this 3 comes from this. So 8 equals this calculation here, and solve that. Okay, so solving that, I multiply by 2, move the 4 over, x2, or the coordinate of the x value here must be 20. Try the same thing for the other half here. The 3 comes from this calculation. All right, if you did the work on that, it should be 13. So now we know this coordinate is 20, 13. And just as we've been doing now find the length of the diameter. So now that you know these two endpoints of this diameter, how long is it? Okay, that's distance formula, and we get a root of 976. All right, let's take this to the next level now. You've had practice with basic midpoint and distance formulas. Let's take this to 3D space. Okay, maybe you've seen this, maybe you've never seen it before, but we're going to talk about 3D space now. You are used to x and y coordinates. That is in 2 dimensions. But now when we take representation of coordinates in 3D space, here's what it looks like normally. Our x and y axes go here. Normally we would have like, this would be x, and where we see z here would be y, right? But now the 2-dimensional surface we began with is like the floor here, x and y, and then now going up into 3D space, we have a third axis, z. So just remember this order here, x, y, z. All right, and we can have any coordinate in 3D space labeled like this. We have point A here, and notice we give the coordinate of it as x, y, z. Just like before, we just say an x, y coordinate, now it's an x, y, z coordinate. Let's take a look at this. So in 3-dimensional 3D space, the location of any point is determined by an ordered triple. Before, this was called an ordered pair, now this is called an ordered triple of coordinates x, y, z, where each coordinate determines the location along the x, y, and z axis. Okay, so let's look at some points and see if you can label their locations. Let's say this point here. I'll help you with the first one, and then you'll try a few. This coordinate, well, we need to give the location of it using 3 numbers. So first we do the x location, right? So from the origin here, the corner, 1, 2, 3. The x value is 3. What's the y value? Has it moved along this axis? Well, no, this point is sitting right on this line. It hasn't moved to the right along the bottom here, right? So the y value is going to be 0. And has it moved up the z-axis? No, this point is remaining on the floor. It hasn't gone up. So the coordinate is 3, 0, 0. It's moved 3 in the x direction, nothing in the y direction, and nothing in the z direction. All right, see if you can do the next one. What are the coordinates of this point? What's the ordered triple for this point? All right, that one is 0, 6, 0, y. It's moved 0 on the x-axis. It's moved 6 along the y-axis, and it has not moved up, so 0 on the z-axis. Let's try a few more. How about this one here? Okay, I hope you got 0, 0, 4 for that one. Again, this one has not moved along the x-axis, not along the y, but has moved up on the z, so 4 units up on the z-axis. All right, a few more. We're not done. How about this one right here? That one is at 5, 4, 0. 5 along the x-axis, 4 along the y-axis, and has not gone up, so 0 on the z. All right, finally, we've arrived at point A, the one that's on this diagram. What are the coordinates of that? What do you see here? And I would say it's hard to see it here, so follow these little markings that's shown us on the floor here to help you get the exact location of that. So you can see that point was at 688. I hope you got that. Let's double check that one. X coordinate, well, to get to this point, it shows us that point is hovering above this point on the floor here. So we got 6 units on the x-axis, then 8 units on the y-axis, and then we went up, and you can count how far it went up from here, and that's 8 units up on the z-axis. There's our coordinate. So now that you're a little bit used to finding points in 3D space, we're going to apply the distance and midpoint formula in 3D space. Let's take a look at how that works. First of all, here is our midpoint formula in 3D space. Notice it's exactly like the midpoint formula we had before, but now there's a third coordinate, and it's the z one, and we do the same thing. The average of the z point locations gives us that coordinate. So same formula, just added the z bit here. And likewise, distance formula, same formula we had for distance, except for now we have also a third part with the z coordinates here added and squared as well. Same formulas, let's try them out. A lot of students find these problems a little more tricky, so let's see if we can break it down. You need to have some good visual spatial skills here to be able to see what this looks like and what we have. So take a look at this cube here, and this, well, it's not exactly a cube actually, because the sides are not all the same length. But we can see this triangle, a green triangle within it, and that has to do with the problem. Let's read the problem. We have a storage box for garden tools. It is in the shape of a cuboid. A cuboid represents any 3D box-like shape, okay? And then it gives the name of the cuboid with all these letters. Basically, all the vertices are listed, okay? And notice the vertices are listed in an order, O, C, D, R. This is important. O, C, D, R, and then F, B, A, Q, F, B, A, Q. So the order, notice, shows you around the base first and then around the top. So remember that, because it'll be important in questions where you're not given a diagram and you're given a name, like the next question you'll see in a moment. But we have this cuboid, and the vertex A is given to us right here, and that vertex is at 2, 3, 4, and I kind of just highlight it there again just so we see it. That right away, given a vertex, we should be able to figure out the lengths of the sides of this cuboid. So how long is this side right here? OR, how long is that? Well, that must be 2, because the first value here is your x value, right? So from the origin, we go 2, to get to A, we go 2 units this way first, and then 3 tells us along the y-axis, so 3 units this way, so that must be 3. And then to get to A, we see our z value, 4, so we go up 4 to get to there. So basically that coordinate has told us also how long the sides are here. Okay, now it says, what are the coordinates of vertices R, C, B, and Q? So look at R, C, B, and Q, and what would be the ordered triples for those ones? Try it out. All right, here they are. Here's R, here's C, here's B, and here's Q. And I won't go over the details there. I hope you're successful. If not, take a close look at the ones you got wrong and double check. You know how you're finding those. All right, now the maximum length, we need to find the maximum length of garden tool that can fit in the storage box. Okay, imagine this is a blue box you have in your garden. You're putting tools in it. What's the longest tool you could put in there? Would it be standing straight up? Would it be laying on the bottom? Well, no, and that's where this green triangle comes into play. That dotted green line right down the center here, that's the longest thing you could fit inside this box. It goes from the back corner in the top to the front corner in the back. That's the longest thing you can fit in any box, okay? So your job is to find that length. How long is this tool from B to R? And of course you're thinking, well, there's kind of a right triangle there. Maybe I can use Pythagorean Theorem. Sure, but also we know the distance formula. It tells us the lengths of segments. So find the distance from B to R and you will have your answer to question B. Try it now. Okay, there's that green triangle. Here is the distance formula that we learned is now in 3 parts because we have X, Y, and Z coordinates. And here is the length of the garden tool, which is this length here. Okay, great. So now the last thing to solve is the angle between the diagonals BR and BQ. So look at BR is that garden tool length, the dotted line, and BQ is this top line. We want the angle between this green thing and this green thing. In other words, this corner angle, the green angle up here, that's this angle here in this diagram. Do we know anything else about this triangle? It's a right triangle and we need an angle. Your brain should be telling you trigonometry. Okay, we know this side is 4, and we know this side. Oh, 2 sides, and we need an angle. You can definitely use trig. Which trig ratio would you use? Sine works here. Opposite over hypotenuse. Solve that by doing an inverse sine to get the angle. And we should get 48 degrees. All right, this is how the course is going to go. We're going to use all our knowledge as we learn. So just because our trig unit finished, it doesn't mean it's over. Remember all the tools we learned along the way. We're always going to use them. Okay, last question. It gives us a cuboid here, tells us the dimensions, and it tells us 4 of the vertices. And notice they are the first 4 here in the cuboid. So that would be like the base of the shape. Sketch it. So try to sketch it. Again, the first 4 represent the base, and we have the coordinates here. See if you can sketch 3D space. All right, and I'll give you a hint to begin with that, right? Here's our X, Y, and Z axes. All right, sketching it, well, here's point A, B, C, and D. Those were given to me. I know they're the base because I can see them here, 4 in a row. I have them here. I'm going to connect those. All right, and now you are given one more dimension here, because we can see here, this is 4 units, and here is 5 units, 4 and 5, but we have another dimension in this cuboid. Oh, 2. That means it must have a height of 2. So there's the 4, there's the 5. It must have a height of 2. So that automatically tells us where the whole top of the cuboid is. So I can go 2 up here everywhere, and there I have the upper part of this cuboid. So now it says determine the coordinates of the upper vertices. So what are the upper vertices coordinates? And notice the letters match the bottom letters, with A1 being directly above A here, B1 being above B, and so on. So what are the coordinates? Okay, there they are. And the coordinates, oh, I didn't label them, but I labeled C1. So how about you check C1? All right, because the next question says determine the coordinates of the midpoint of diagonal AC1. So if you go from corner A to C1 here, what is the midpoint of that diagonal? So now let's use the 3D midpoint formula to find the midpoint of that. All right, here's the 3D midpoint formula. It gives us this coordinate here. I hope you had some success. And then look at question C. Take a look at that. And would that segment have the same midpoint? And look at the answer here. All right. Great job. We will see you soon.